Hello. Today we shall discuss about operational amplifiers. Before we go into operational amplifiers, which we have discussed in few sessions earlier, today we are going to deal with few common types which are available in the market so that we use them in proper fashion. Before going into that, let me give an overview of how the power supply is given to an operational amplifier. In most of the academic sessions, we understand that the power supply for an operational amplifier is like this. It's called a split power supply, where we have positive of one battery, negative, and then again this is positive and negative, both are connected in series, and the center point is grounded, and this is called VCC, that is positive, and this is called VEE, which is negative. This is typically the power supply which is used for operational amplifiers as we have read in our academics. But in real world, such kind of power supply arrangement is rarely followed, rather it is never followed. We follow a simple power supply which is this way, what we understand. We have a VCC and we have a ground. So simple, because we can't afford to take two batteries and have a center connection of that as we have seen here in this arrangement, because this is not practicable. It is not practicable. That's the reason why we first thought of discussing about how the power supply is given to an operational amplifier. And now we will try to discuss. We have seen that the comparator in certain earlier sessions, and we will come back to that again, that how the comparator is used as far as several types of operational amplifier is concerned. And let me go over to certain data sheets so that we can know them better. Now, for example, if we take a operational amplifier called LM324, LM324 has got 4 operational amplifiers inside, right? And this is called VEE, or we can give it ground, and this is VCC, pin number 4 and pin number 11, and it's got 4 operational amplifiers. Unlike the very common one which we read in our academics is 741, where it has got only one operational amplifier inside this IC. It's got an 8-pin IC and it has got only one operational amplifier. Similarly, if you go for LM358, this is an LM358, this has got 2 operational amplifiers. It's an 8-pin, and again, but it has got 2 operational amplifiers inside this. And if we go to LM324, it has got 4, and if we go to LM339, this also has got 4 operational amplifiers. This is a 14-pin IC. LM339 is a 14-pin IC, and LM324 is also a 14-pin IC. But mind it, the pins are may not be compatible. For example, if this output is 1, input is 2 and 3, as far as the LM324 is concerned, and if we go to LM339, it is output is 2, input is 3 and 4, and this output of 1 of this operational amplifier, input is 6 and 7. So they are not pin compatible. Though they are 14 pin, both are 14 pin, they are not pin compatible. We will discuss as to how they are not pin compatible and what are the difference between those operational amplifiers in their actual use. So what we have discussed about 741, a single pin, a single operational amplifier, and then we have LM358, which is commonly used. It's a dual operational amplifier, and then we have LM324, which has got 4 operational amplifiers, and we have got LM339 or LP339, which has also got 4 and operational amplifiers. The other important issue of these, there is a glaring difference between one particular IC, which is LM339, this is LM339, and all other operational amplifiers. That is actually called the open collector concept. What is open collector concept? We will explain it in the simulation, but let me show you what is LM339. If we go to LM339 data sheet, that you find. This is the internal structure of the LM339, where the output pin, the collector, comes directly from the IC. Directly from the IC, it is not connected internally anywhere. So that is why it is called open collector. But if you go to LM324, its output is internally connected to some resistance and some arrangement inside the IC. We will see how it makes a lot of difference when you talk about internally connected and internally not connected. Now let's go over to the circuit diagram where we are using a LP339 or LM339, all are same, and we have taken only one operational amplifier out of that, and we would like to see how it behaves. We have discussed this in earlier sessions, but let's now see this, how we understand how the current flows, and those are the arrangements. Now let's power this. Once we power this, we find that this particular voltage output is equal to 0. Why? Because plus more than minus, output is equal to 1. We have discussed as far as the comparator formula is concerned. Here plus terminal, that is the we are calling it intentionally plus and minus, as we have discussed earlier, that plus is for the non-inverting and minus is for the inverting. Instead of calling it a long word, we are calling it plus and minus. So plus is at 2 volts now and minus is at 3 volts. So obviously plus is less than minus, output is equal to 0. When it is 0, naturally the current is not flowing in the transistor, so relay is like this. Now once I increase this, you see, now this voltage goes high, output goes high. It is not showing higher 12 volts because we are directly connected it from the output of the at the base and emitter junction, so it is showing that voltage, but anyway it is going high. Because of that high, this has changed, relay has changed, current is start flowing in the collector emitter of the transistor, and the relay switches on. In the process, this lamp is switched on. This is as far as LM339 is concerned. The other important thing that we have to see in the LM339 is that this is what we said, is that it is an open collector arrangement. If you recall the LM339, it's an open collector. It's an open collector. You see, the output is open collector. That is the reason why we have connected a resistor from the supply to this point. Otherwise, this is not going to work. For example, if I remove this now, right, and I want to give power to this, whether I give it higher voltage or lower voltage, the output is not coming. The reason being that since it's an open collector, this can never become high. This was becoming high only because the resistance was connected here. In contrast to LM324, which we had seen, LM324, if you look into LM324, the internal structure of LM324, it is already internally pulled up. Because it is internally pulled up, then it has a different it automatically goes high. Now let's see it more in detail, and what is internally pulled up and what is externally pulled up. See, there is a transistor which is open collector. So the output of this particular IC, the output pin number 1 is like this. There is a collector which is open collector. Because it is open collector, unless I pull it up externally, what we had done it before, we had pulled it up externally, then only it becomes high, otherwise it cannot be high. As compared to LM324, it is internally pulled up. It is like this. It is internally pulled up, where there is a resistor which is connected internally, and this is what the pin number 1 of LM324. All other ICs what we discussed about, whether it is 741, whether it is 358, all of them are, the output is internally pulled up. It is not open collector. So coming back, the open collector has certain advantages like this. Now we go over to the LM324 now. We saw that LM324, how the LM324 works. Here we have not pulled up. which we have not pulled up this resistor, because we know this is internally pulled up. Because this is internally pulled up, now when I power this, it works the way. Now if this voltage is 2.9, this voltage is 2, so this is 0, that is plus is less than minus, output is equal to 0. Now if I make it high, you see this becomes high. You don't go by this voltage reading. High means the supply voltage we have said, but this is directly connected to the base emitter circuit. We can always connect a series resistor here, but then it goes high. In the process, the current flows in the collector emitter circuit. In the process, the relay operates and the lamp operates. You see it, we have not connected any pull-up resistor here because this is internally pulled up. So these are the difference what we see in the standard or the very popular operational amplifiers used as comparators. Operational amplifiers, we also know they are used as amplifiers. We, for our purpose of application here, in many applications we are only using them as comparators. So this is what is the different type of comparators used in electronic circuits. For one is open collector, one is not open collector, internally pulled up. Okay, thank you.